Hello and welcome back. This week we're going to be talking about the difference between hard and soft clipping in guitar pedals. Basically speaking, the difference between hard and soft clipping generally is what you would hear in a distortion pedal for hard clipping and an overdrive pedal in soft clipping. What I'll do is put some diagrams on the screen now and we can walk through it. As mentioned, hard clipping is generally for distortion, soft clipping is generally for overdrive. There's fine lines there here and there, but for the purpose of this, let's say it is. Basically what's happening is the sound signal through a pedal is just a wave. It's your sine wave going up and down. The clipping is what happens to that wave. So for hard clipping, what we're seeing is a harder, more squared off sine wave. And for soft clipping, we're seeing a more rounded clip of that wave, making it less distorted, giving it a little bit more of that organic sound. Originally, that soft clipping came from an old tube amp getting pushed too far and starting to distort. It's not that heavy distortion, just that lighter distortion. And that was recreated in various guitar pedals. Of course, after that, there's fuzz, which is more of a squared off wave. So if you have something like the hard clipped, there's still a little bit of roundingness to that wave, whereas a fuzz, it's a harder keeping it square. All in all, like with these diagrams, it's a simplification though of the different way things are clipped. Clip signals do have different shapes. It's not always going to be a perfect square or a perfect soft clip. The way things clip are going to be different shapes and different iterations of that sine wave is what is going to give the sounds that are unique to different pedals. Today we're going to go through some pretty famous circuits to look at how soft clipping and hard clipping are different. The circuits I'm looking at today are the Tube Screamer and the Rat. Tube Screamer being for your typical overdrive pedal, so that's going to be our soft clipping example. The Rat being a great distortion pedal being our hard clipping example. So let's take a look at these two circuits before we break out the breadboard and see what they look like. So here we have a schematic for an Ibanez Tube Screamer, one of the more famous overdrive pedals out there. I have a full rundown on how to build this on breadboard, as well as how to build it on strip board if you want to build it permanently. Fun project, not too difficult, but not a beginner project because it's quite a big pedal actually. But it's fun, and then you have your very own Ibanez Tube Screamer. So let's quickly walk through what's happening here. Basically, I'm going to talk about up until the clipping stage, and this is the soft clipping stage of the Tube Screamer, and that's pretty standard soft clipping that you'll see in a lot of other overdrive pedals. But a few things just to point out. This is not going to be a full deep dive into the Tube Screamer, but just to understand what you're seeing in the schematic. Up here is the power section, and in the power section we've got power coming in, a few little just regulators there. That's just to smooth out the DC power. That's just voltage protection. Here you have what's called a voltage divider, and I'll link an article on how voltage dividers work to give some theory there. But basically all we're doing is we've got two resistors here of the same value going into ground. So we know through Ohm's law that there will be a drop of 1/2 of the voltage there, and then the other half it will go to 0. So we know there it's half the voltage of what's gone into it. So we're sending 9 volts in, and what's coming out here is 4.5 volts. And of course we've got our 9 volt there, which is going to ultimately power our op amp, as well as this transistor here. What we want to do when it comes in is what's called biasing the current. And the current is an AC current, so it's going up and down in that sine wave that we discussed, but that's around 0 volts. What this is doing is, rather than it going up and down around 0 volts, it's going to be going up and down around 4.5 volts, which just kind of gives more headroom for the clipping to happen in this DC area of the of the clipping circuit. So we're just going to bias it with 4.5 volts, boost it a little bit with this transistor. Last time, if you want to take a look at my video on building a simple distortion pedal, I'll link it either there or there. I never know where it shows up. I'll put a link up here, and you can watch the video on building a simple distortion circuit, and we do that with a transistor boost, and it explains a little bit what's happening with the transistor boost like that. I've just found, although the tube screamer does have plenty of grunt to it, the op amp being used doesn't actually have as much gain to it compared to the Rat, which we'll look at in a second. So it's going to get boosted a little bit. And now we have the amplification stage. And there's a couple ways to amplify using an op amp, and this is a pretty standard way to do it. Putting the signal into the non-inverting non-inverting pin, and then feeding it back and it coming back out, and that's going to amplify the signal. So what we're doing here, and if we forget about these diodes and this capacitor here, so just ignore them for now, using an op amp just as a general amplifier is comes out and we feed the signal back and back in. And what we can see here between this potentiometer and resistor pair, consider this one resistor for now. So we got a resistor here and a resistor here. And it might be hard to see, but that's the same setup as this voltage divider here. We have one resistor and then coming off in the middle, and then another resistor going to ground. So that's creating a voltage divider. We can forget about that cap. That capacitor is just there to smooth out the signal a little bit, but all we've got is a voltage divider here. And without going into kind of the voodoo that is operational amplifiers in a lot of ways, the difference in that voltage from what's going in and going out and going back in is what is going to be amplified. So if you're putting in, say, 1 volt, and we have a difference in voltage of half a volt, you push it back up again. And that's basically what's happening in an op amp. Very briefly, op amps are kind of difficult to understand the science of, and to me, sometimes I treat them like a black box, honestly. But all you need to know is the signal goes out, voltage divider happens, and that difference in voltage is what creates the amplification process. And then it comes out, and you get nice noises. In soft clipping, as you can see here, we've got 2 diodes of going different ways, one going that way, one going that way. And that is what's clipping the signal. Because basically, with a diode, as we heard on the distortion pedal, if you push it past the voltage that the diode is designed for, it gets kind of annoyed with you and clips off the signal. And so you do 2 different directions because we got the AC signal, and sometimes it's running this way and sometimes it's running that way. And so you can be able to clip both the top and the bottom of that AC signal. And in this setup, we're getting a soft clipping situation. Then it goes out. Here is the tone control for the TS-808 if you're interested in it. Won't go into it too much, but we're going in, we're boosting the signal again. Over here, we've got a potentiometer, so we can change up what the value of this voltage divider is, and therefore change the gain. Here it's going to be a constant gain. And then we've got basically a low-pass filter here, and we adjust that with this potentiometer here. There's a lot more going on than just that, but that's very basically what we're talking about. So that's what's happening in the clipping stage for a soft clipping pedal. And whether it's the tube screamer or something else, generally speaking, this is the setup you're going to see. The 2 diodes in that feedback loop of the op amp. Now let's take a look at the clipping stage for a Rat and try to understand what's going on there. Now this is the schematic, or most of the schematic, for a Rat distortion pedal, and we can see there's some similarities here but once again, differences. So this one isn't boosting the input, but once again, we are biasing it. We've got same thing, a voltage divider here to make it so that we got 9 volts in and we got 4.5 volts coming out. So we're going to bias the current a little bit here, and then there's a little low pass filter here. That's just because either what they want to do is put a specific tone into the pedal, or just a filter to get some junk out. Same thing though, into the non-inverting part of the op amp, and then we see that feedback loop again. We have a potentiometer here, and then this is kind of unique to the Rat, but it's the same thing. We got a we can almost forget about this resistor here, and we got a resistor coming off, creating this voltage divider. And the way I've done the schematic, we can more clearly see the voltage divider happening between one resistor, 2 resistors, and something coming off the middle. So once again, we're having the same amplification. We're seeing a couple capacitors within those feedback loops as well. That is mostly, and you saw that on the tube screamer as well, that's mostly just to remove some frequencies, stop oscillation, and give a specific tone to the pedal itself. I wouldn't omit them because it will probably sound like crap, but they're really not there for amplification purposes. The big difference that we can see, of course, is there's no diodes in that feedback loop. Instead, once it's amplified, it comes out at a higher voltage than when it went in, and then we have these 2 diodes going to ground instead. And what that's going to do is create that hard clipping. More clipping, more of everything, the parts of the sound are getting sent out of the signal and down to ground, and that's what's creating that hard clipping. But really, for all intents and purposes, we saw the TS-808 and we saw the Rat. That amplification stage is the same. It's just what we're talking about is the placement of the 2 diodes. From there on the Rat, come out, I think that's a little bit of tone control. Yes, that's tone control here. That's a very simple one compared to the tube screamer. All we're doing is a low pass filter where we're adjusting how much resistance is here compared to this capacitor. I've explained that briefly in the last video, but very briefly, you have 2 ways, two filters basically. You have a low pass filter, which is a resistor, then a capacitor going to ground, and that lets through low signals while cutting higher signals. And you have a high pass filter, which is a capacitor, then a resistor going to ground, and that's going to allow the high signals through while cutting the lower signals. And it's the ratio between the resistor and the capacitor which will determine what is being cut. Which is why you simply adjust this potentiometer here, and that's going to adjust the frequencies that are being cut. There is some science behind it, and I have a whole article on the science. The science actually makes a lot of sense. If you take the time to read it, I'll link that in the description. From there, boosting the signal a little bit, it got cut off by the printer, but then basically out. But that's basically a Rat. It's actually quite a simple circuit when you look at it. Not a lot going on, but it works, and it works well. So let's take a look at a couple breadboarded circuits here. One for the gain and clipping stage of a tube screamer, and one for the gain and clipping stage of a Rat. What I'll do is we'll run through the tube screamer first. We'll see what it sounds like, and then we will run through the Rat, see what it sounds like, and then I'll edit the video so that you can hear it side by side. Cool. So here is the breadboarded circuit for the tube screamer, just up until that clipping stage that we saw on the schematic. What I'll do is, you can see it here, it can be hard to kind of decipher with this view, so I'm also going to create the same layout but just on a computer. I'll put it up on screen as I'm speaking right now so you can see it, and it will be a little bit easier to follow along with if you want to build it yourself. So that's on screen right now, and just pause, take a screenshot, and you can follow along yourself if you want to build this and experiment with it. But just compared to the schematic, what we have is we've got the voltage divider up here. So what I've done, and this is just some basic breadboarding, On the top, very top, that plus there, so that's positive. We got our 9-volt coming in, and then below that is the ground. And on the other side, what I've done is I've jumped the ground from there to there, so I also have a ground going along the bottom. But I've got the voltage divider here, and then the 4.5 volts coming out of the voltage divider. So I've got the top up here at 9 volts, and I got the bottom down here at 4.5, and I can use that as I need it. Here is that boosted area with this transistor. We've got just those kind of input capacitor and resistors going into the transistor, bringing my 9 volts in down to there, and then the biasing current coming in from my 4.5 volts. Then that is going through just a capacitor. That's probably a DC blocking capacitor there. And then we're going into the op amp. And here's our feedback loop here, where we have the 2 diodes going in different directions and our resistors, and then the one going to ground to create that voltage divider for the op amp. And then coming out of the op amp, boom, out, it makes noise. So let's have a listen to this and see what soft clipping sounds like. What we notice with soft clipping is it gets affected by the attack. So if you are playing harder, you're going to get more sort of weird clips. So that's why I in that little demo, I put a little bend in there, because soft clipping responds really well to bending, and you get some weird harmonic noises coming through. It's a real bluesy sound, great for classic rock before they actually had distortion pedals. But the harder you hit a soft clipping circuit, the harder it's going to hit back. So, you can also hear it is a distorted sound, but it's not distortion in the way a guitarist would talk about it. Let's have one more listen, and then we can have a look at how the Rat sounds. And then for curiosity, why don't we also just really quickly take these diodes out, and you can hear that basically all that's happening without the diodes is getting amplified as I turn this up. There will be a little bit of clipping thanks to the op amp, that's just how it works, but we'll take these diodes out so you can hear that. Let's have a listen. So yeah, you can hear it got louder. A little bit of clipping from that op amp, but that's kind of by design in this circuit. At least you can get cleaner clipping op amps, cleaner clipping transistors, or well, cleaner op amps and cleaner transistors. Just the way that this one is set up, it's going to clip a little bit, but it adds a little bit of character to the pedal. Now I'll swap this out, put a quick cut in, and we can have a listen to the Rat. Great, so here is the Rat all done out on the breadboard. You'll see some similarities here. We've already kind of gone through it. Again, we have the voltage divider over here. I'm using the top for my 9 volts, and then I'm pushing the 4.5 volts down to the bottom, and I'm also jumping the ground across. Here's that little, just a little bit of filtering coming in, and then we're going into the op amp. It's a different model op amp, so you're actually, not all op amps are made the same, meaning that the legs of the op amp are often different. So don't take for granted what you might see here or what you might see someone else build, because they might be using a different op amp. Always look up the model of the op amp and what the different legs do. So on the Tube Screamer, all my ins and outs were on one side, whereas on this one, we've got the out actually coming out of the other side of the op amp, so I've had to jump that around here. But we're going in, and then here's your feedback loop with your potentiometer, and then this resistor going to ground. I've chosen to omit that pair of resistors and pair of capacitors. I'm not sure why they did it in pairs. I just used the formula for resistors and capacitors in parallel and used something of similar value, especially for this example. It makes it a little bit cleaner. And then we're going out, comes out, and then through just this filtering capacitor, and then here are our two diodes going to ground. Real quick, I'll put this up on screen, a computer version of it, so that it's a little bit easier to look at and a little bit easier to follow. So if you want to make this at home, you can take a screenshot of this and follow that a little bit more than looking at a bird's eye view. So let's take a listen. You'll hear that this is more what you would imagine as distortion. What's also cool about the Rat, it does give a little bit of softer clipping in the early stages, and then gets really, really ballsy and really distorted. Cool. So we can hear on that, there's obviously a lot more. This is more akin to what we think of distortion rather than that overdriven classic rock or bluesy sound. And even in the chord work, that's nice and distorted, where it was the single note lines, even with the bends, it's a little bit more even. You don't get that scream as a big bend and with a bigger attack. But that's just the nature of distortion. It's a little bit more compressed, a little bit more even. What I'll do is now remove these two diodes just to prove to you that, once again, we have just an amplifier. Doesn't take a lot on this circuit. What's interesting, once again, we're getting a little bit of clipping coming out of the op amp. Once again, that's by design. You can always get a clean op amp if you want to do similar circuit with a cleaner op amp. What I'm going to do now is I'm going to edit in the clips of the sound side by side so that you don't have to listen to me babble on about it, so you can hear side by side the Tube Screamer going full bore, and then I can play the Rat going full bore, and you can hear that difference between the soft and the hard clipping easily side by side, so that you know the difference. So that's the basic difference between hard clipping and soft clipping. Generally speaking, when we're talking about hard clipping, we're talking about a distortion pedal, and when we're talking about soft clipping, we're talking about an overdrive pedal. For both these circuits, I've shown the schematic as well as put a picture that's easy to follow on screen for you to take a screenshot of, so you can make them yourself on a breadboard at home, experiment with it, see what different values do, see what removing a piece does, have fun with it. I'll also link in the description to various articles that will that kind of extend on what I've talked about, whether it's voltage dividers, diode clipping, things like that. If you want to, you're welcome to read the articles or just make some noise and have some fun. If you enjoyed this, feel free to comment, like, subscribe, all that sort of stuff. Thank you for watching. I hope you enjoyed it. I hope you learned something. See you soon.